Okay, so, the one you chose was number 153. I'm just going to write this out. Integral of c over c of x e to the negative 2x dx plus x to the fourth plus 2x squared y squared dy. And the region is the region between the circles x squared plus y squared equals 1 and x squared plus y squared equals 4, which is a circle at, centered through origin, radius 1 to radius 2, right? So that's very easy if you see that. Pass that back on over. Okay, so we want to convert this. So here's our p, here's our q. This is going to equal the integral over the region, okay, of qx, which is 4x cubed plus x squared y squared. Actually, we can factor out an x squared, okay? Then it's minus derivative of this, which is e to the negative 2x minus 2xe to the negative 2x. And then that's with respect to area. We can simplify this a little bit. Four x squared times x plus y squared. Plus 2x e to the negative 2x minus e to the negative 2x. And we'll probably leave it like that. There's not much point in trying to factor that. Now, I said originally that we probably want to do this in polar coordinates. But, that's going to be a little complicated because we're going to have r's and thetas and all that stuff, right? Okay? But we still can kind of do it. The integral is very simple. We have fixed limits on the integral here. In other words, theta is going to go from well, let's do theta last, 0 to 2 pi. And r is going to go from 1 to 2. That's an r dr d theta, except we got to, of course, put the x's and the y's into this. So that's the integral from 0 to 2 pi, from 1 to 2 of, what's this? This is 4r squared cosine squared theta. And probably going to go ahead and expand this back out to the original form. 4r cubed cosine cubed theta, right? Plus 4r squared cosine squared theta. And then it's times r sine theta, which raises this r to a cube. And then we can factor the 4r cubed out of that, right?
You have a sine squared.
Yeah, you're right. And, yeah. Okay. And then over here is where it might get a little tricky, but probably not.
Which would make that r to the fourth instead of an r cubed. Right before
You're right.
cosine.
Because that's where you're going to have a fourth here. Okay. Then you got 2x, 2r cosine theta, e to the negative 2r cosine theta, minus e to the negative 2r cosine theta, r dr d theta, right? So that looks a little intimidating. Mainly, you can integrate the sines and the cosines. That's not a problem. You know how to do that. And if you don't, you need to, of course, review it. What are you going to do about this? Okay? So that might be a little bit tricky. This one might work out because you probably do a substitution of some sort. This one,
Wait, don't they cancel each other out?
I'm sorry,
Give me your hand for a second.
can't hear you.
Oh, never mind.
Yeah.
I mean, you could take out the e to the negative r cosine theta and make it a 2r cosine theta minus 1.
Not sure where you get a cosine theta minus 1. If you get rid of the negative 2, you have to do that by saying it's like e to the r cosine theta quantity squared.
Taking the e to the negative r, 2r cosine theta times 2r cosine theta minus 1.
So factoring out the e
Factoring
part.
out the-
The what?
Factoring out the e part.
We can't factor out the e part here because this is all the exponent. It's all e.
I'm talking about for both.
Anyhow, we're out of time. I'll let you kind of puzzle over how to do that. Whether that's really the best way to do it or whether we just got to come back to integrate this in rectangular coordinates. Okay? And then, of course, it could be just easier to parameterize it and do it up here, but if you parameterize it, you're going to have the same stuff popping up, okay? And if we had time, we'd go ahead and do it. Okay, play around with it and see what's going to happen.
Maybe next week.
But
That does remind me.
we got a snow day for the rain.
Do we have laptop?